is going to be these three that I'm going to give you today. Okay, there's three ways you can prove triangles are similar to each other. The first one is called just angle, angle, and I just abbreviate that with AA and then that little similarity symbol. So angle, angle, similarity postulate. Literally all you have to have. Two angles in one triangle are corresponding and congruent to two angles in another triangle. So like this one, angle R, angle L. Those are corresponding angles, they're congruent to each other. T and P, corresponding, congruent to each other. If you have that, just having two angles, that is enough to say they're similar. Not congruent or anything like that, but they're similar to each other. It means same shape but different size. So I'm just going to write my little similarity statement here in a second, but I have angle R and angle L, so that's one set of angles. I have angle T marked congruent to angle P, so it's two sets of corresponding and congruent angles. If you have that, that's enough information. And I'll just write a similarity statement real quick. Let me call that first one SRT is similar to, let's see, it'd be MLP. There's different ways you can write the similarity statement, just as long as you're matching up the corresponding parts. So that's just one way to write it. That would be my similarity statement. Now, in that particular example, and a lot of times this will happen, you don't have enough information there to give me a similarity ratio. So I could still say the triangles are similar, but I don't have enough information to give a similarity ratio for that example. So that's okay. Now, the other two, you should be able to give me a similarity ratio for because it's going to involve sides. All right, so the second one's called side angle side. So I just call that SAS similarity. And this is similar to side angle side when we were doing proofs, but you're going to have an angle in between two sides. So in this diagram here, angle A, they got to give these are exactly equal, so those are congruent. Now the difference between this and a congruence is you're going to show that these corresponding sides are in proportion. All right, so the side where I have the 4, and I'm just going to put the bigger or the smaller number on the top. So 4/8, I would have to show that that's in proportion or the same as the other set of sides, which would be 3/6. So you got to kind of ask yourself that question. If those reduce to the same fraction, 4/8 is 1/2, right? 3/6 is also 1/2. So as long as they reduce to the same fraction, that will let you know they're similar, and that would also give you that 1/2. That is your similarity ratio. So some of the questions will ask you for that. Similarity ratio is just what you get when you show that the sides are in proportion and throwing things. And let me write a similarity statement here. So something like maybe triangle CAB similar to triangle RPQ. So side angle side. So two sides that form the angle in between. If you can show the two sets of sides reduced to the same fraction and those angles are equal, side angle side. Okay, the third and final option. I have no angles marked at all. You have all the sides that you would need to know. So this says all the sides, we're going to show that these are in proportion. So if you're not sure, I just pick the biggest number in each triangle and match those up. And then I pick the smallest number in each triangle, match those up, and then the third side is going to go together. In this triangle, they're kind of set up that way, so it's a little easier to see. But you would need to show that each of these sets of sides are in proportion. So I'd need to show, I'm just going to put the smaller number on top, like 10/15 would have to be equal to 8/12, would also have to be equal to 12/18. So this is what you're going to question here if you want to use side, side, side. Are all these equal? Do they all reduce to the same fraction? So each one of these, let's see, 10 and 15 are both divisible by 5. So that would reduce to 2/3. 8 and 12, let's see, both divisible by 4, also 2/3. So I'm just checking each one of these. 12 and 18 are both divisible by 6, also 2/3. As long as they're all the same, that means with side, 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 I can show that these triangles are similar. And then also, if you've done that work, that is your similarity ratio as well. Now, a lot of the time, the angle, you can't give a similarity ratio, but you can say the triangles are similar. Side, 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 or side, angle, side, you should be able to tell me if the triangles are similar and the similarity ratio. And just to be consistent here, I'm going to write a similarity statement. So, question? Yeah, go ahead. All right, so CAB, if I do that, I would have to say is similar to match up corresponding parts FDE. Does anybody have any question? Okay. Now, basically what you're going to have to do is they'll give you some kind of a diagram. That's what I got going on in example 1. And then we're just going to decide, is there enough information in this picture to show that these two triangles are congruent? All right, so I kind of started with one I think is a little trickier here. You kind of have a triangle inside of another triangle is what's going on here. And what I would just maybe recommend just to help do the problem would be to separate those two. So I just kind of outlined one on mine with my yellow highlighter. I'm just going to draw these to the side so you can see them a little bit better. And see if you guys can label these, because I think this can be a little bit tricky. So the one I drew in yellow, that's K, L, and P. And the one I kind of outlined with my purple marker is K, this is M, and this is N. Okay. Now, on the little yellow one, right, K to L, they have an 8 there, and K to P, they have a 12 there. If you look at the triangle that I outlined with my purple highlighter, what would you tell me the length of the side from M to K is? Exactly. Just like 8, 2, so this whole side would be 10. I want to separate these because it'll be easier to see what corresponding sides I can match up. What would the whole thing from K to N across the bottom be? Perfect, perfect, 15. Okay, now, what we want to check is if we can prove these congruent. So our options, angle, angle, side, or side, side, side. I don't have all 3 sets of sides. I don't have any angles marked at all. I do have 2 sets of sides. Here's what I would show you here. Would you guys be okay with me saying angle K there is in both of those triangles? Can you guys see that? Like angle K is in both of these triangles. So I would have, if I was doing a proof, which I'm not, I could just use a reflexive property on that. So angle K is in both of those. Now, that angle is between the 2 sides that I know in each of the triangles. So if these are similar, we could use side, angle, side. But to do that, I have to make sure the sides are in proportion. So you have to check these real quick. So the 8 and the 10, those would match up as corresponding sides. The 12 and the 15, those would match up as corresponding sides. If I can show those are in proportion, then I can use side, angle, side to show these are similar. So we're just going to check these. Just 8 over 10. I'm seeing if that is equal to 12 over 15. So do these reduce to the same thing? Yes, what do they reduce to? 4/5. Okay. Now, if you do that work, you've already determined your similarity ratio. So I'm just going to come write that on the line here real quick. And I just asked in the directions, I didn't say this, sorry. It says similarity ratio smaller to larger. Smaller to larger just means you put the smaller number on the top of the fraction and the larger number on the bottom. So 4/5 would be my similarity ratio there. Now, I was just telling you guys this. I had a side, angle in between, and a side. So this is side, angle, side similarity. And if I want to just relate the 2 triangles with a similarity statement, let me call the first one LKP similar to the MKN. Might be easier to do that with the separated triangles than with the original picture when you write that similarity statement, just so you can really see what the difference is there. But those 2 triangles are similar. Okay, does anybody have a question? All right, here's what I have in the next picture. So I have angle R and angle V. So angle R congruent to angle V. That was just given to us. Those are both 45 degrees. I don't have any sides marked in this at all. Is there any other information I could mark in the diagram that maybe is not already marked in it? I don't know if I don't have any like midpoint or bisector or anything like that, so I can't get any sides there. What were you thinking? You do, if you guys, kind of that bow tie shape, we do have vertical angles here, And so, like angle VSB, angle WSR, or if you wanted to number them, we're not doing a proof, but I'm just going to mark it in the picture. Those are just vertical angles right there. Okay, so remember one of the options was angle-angle similarity. So that's enough right there. If I can show two sets of angles are congruent to each other, that's enough right there. Now, this is a good example because I don't have any sides labeled. I can say they're similar, but there's no way for me to tell you the similarity ratio. So if I was doing that, I would just leave that blank. There's just not enough information there. I can write the similarity statement, though. Now, this is really tricky. So I'm going to write the triangle that's on the left side. Let me call that RSW, and I'm going to say that is similar to. Who can raise your hand and tell me, how would I have to label the other triangle to match up the corresponding parts? Because I've got, it's kind of twisted in the middle. So if I call the first one RSW, how would I have to label the other one? VSB, perfect. Okay, so VSB. Is anybody having a question? They're similar. I don't have to write a similarity ratio on that because I don't have enough information, so you could just leave that blank. Okay, now I do want to show you something on this one. I don't have any angle marks on this next diagram at all. They're not connected in any way. We can't get vertical angles or anything like that. They're just two separate triangles. I do have all the sides labeled in each. So the only option here would be for us to do side, side, side. So again, I'm just going to grab the smallest number here, which is 3.2. That would have to match up with the smaller number if these are similar in the other triangle. So these are the sides I want to put together. Then I look for the biggest number. The biggest number here is 8. The biggest number here is 10. So those would have to match up if these are similar. And then the other two, those are in the middle, if that makes sense, would have to match up. Now, this one has some decimals, so I want to make sure you guys know how to do this. But if I want to check if my sides are in proportion here, one of them is 8/10. That's not bad. I could just do that. One of them is 3.2/4, and the other one is 5.5/7. Okay, now your calculator will reduce for you, but you have to have nice plain numbers. You can't have decimals. If you tried to use your fraction key with like 3.2/4, your calculator's going to be like, nope, I'm not doing it. That's an error. So let me ask you this just to make the problem easier. If I gave you 3.2/4, could you tell me what that would be as a fraction, but without a decimal? Do you guys know how to do that? Like, how would I get rid of the 0.2? You may know. Exactly, we're going to move the decimal. Okay, now, literally, this is the 10th place. I'm not going to multiply by 10. I'm going to multiply the top of that by 10 and the bottom of that by 10. So it's really multiplying by 1. 10/10 would be 1. But if you do that, that will get rid of the decimal. So it would just turn this into 32/40. That's literally it. And then you can you can reduce by hand, or you can reduce with your calculator, completely up to you. If I did the 5.5/7, again, I just multiply both top and bottom by 10. This would be 55/70. That would be an equivalent fraction. I'm just trying to get rid of the decimal to make it easier for myself to reduce. Okay, so we're checking to see if these are all the same. They have to all be the same for me to write down my similarity ratio, so we got to check. You got something different? So like 8 over... Right, we can't write a similarity ratio. Here we can, though, because we got numbers for the sides. So 8/10 reduces to 4/5. I think we had that on the front somewhere. 32/40. Both of those guys are divisible by 8, right? So that would also be 4/5. Now, the last one I got to check, 55/70. Let's see. I think both of those numbers are divisible by 5. So that would be 11/14. All right, now, this is a problem for us because that's not the same as the other two. So then these are just not similar. I'm not going to write a similarity statement. I don't have a similarity ratio. One of those sets of sides was not in proportion to the others, so these triangles are not similar. So I would not fill any of that out. I'm just saying they're not similar to each other. Okay, now the one right next to this though, do you guys see? I've got two sides that are 6 here, two sides that are 8 here. I got to check to see if these are in proportion. And then I've got 9, that would go with the 12. Now, I'm not going to write out 3 different things here because I'm going to check 6 over 8. I would check that twice, but I don't need to write it twice. I'm just going to write it once to see if that was in proportion to 9 over 12. So we're just going to see if these reduce to the same thing, but that's really checking all 3 sides there because there's just another set of sides that are 6 over 8. What does that reduce to? 3/4. Good. Okay, so 3/4, and they're both 3/4, right? Okay, now, if they're both the same, we just showed they're in proportion. Now, that is actually right then and there. We just did all the work. That's the similarity ratio. We are using no angles here. I had all 3 sets of sides, and so the reason behind this would be that side similarity. And then if you want to write the similarity statement, there's actually a couple ways you could do this one. I'll just call the first triangle CAB, and then the second triangle, so if I go C to A to B, I'm going to go GFE. These are both isosceles. There's a couple different ways you could write that similarity statement that would be correct. Is anybody having a question so far? Okay. Now, what I would tell you on part E, automatically, these triangles intersect each other, that little X shape, automatically, I've got vertical angles right here, right? So I'm going to mark that in the picture. I have 2 sets of sides in each. So if these were similar to each other, let me ask you this question. If I look at the 18 in the smaller triangle, what number would that have to go with in the bigger triangle? 36, good. So make sure, sometimes these are kind of turned or twisted or rotated, so make sure, like that's the 18's the bigger number, the 36 is the bigger number, those would correspond to each other if these are similar. This guy's 12, the 24, those would go together. That angle is in between the 2 sides. So if these reduce to the same fraction, if we can show that those sides are in proportion to each other, then this one would be side angle side. So we're just going to check real quick. I've got, so 18 over 36 and 12 over 24. Do those both reduce to the same thing? What does it reduce to? Half. Good deal. So these are both a half. As long as it reduces to the same thing, that's your similarity ratio right there. And we said this was side angle side. And this is twisted, so be careful when you write the similarity statement here. Let me call the littler one, I'm going to call it ZVY, similar to triangle. Okay, now I went from Z to V, so I went down the yellow segment in my lovely picture to the vertical angle, so I got to repeat that. The other one I'd have to label to go down the yellow to the vertical angle would be XV, and then I'd go to W. All right, now I have one more. This one is very tricky. All right, you will not be able to write a similarity ratio period for this one because I don't have any numbers on any of the sides in the diagram. You do have 2 triangles here. This is kind of like that very first one we did where one's inside the other one. All right, so there's one triangle, and then the overall around the outside here, BHF. I'm just kind of highlighting this here. Now, in the original picture, I'm not going to separate this just for a second. In the original picture, this angle where B is at, both triangles would share that angle. It's just like overlapping triangles here, so they would share that angle. So I have one set of angles. If I want to prove these congruent, I need 2 sets of angles. If they give you parallel lines in the diagram, which I'm giving you right here. All right, I'm just going to kind of extend these just a tiny bit so you guys can see what I'm doing here. If I have parallel lines, you can do this in 2 different places. If I use this side of the figure as a transversal, where you have BDJ, that angle, and angle F, those would just be a set of corresponding angles. They're on the same side if this is my transversal, and then they're in the same location for corresponding angles. So right there, that's enough for angle-angle similarity, because I just need 2 sets. I got that one at the top, and then I got corresponding angles there. What I also wanted to show you, if I use this side of the figure from B to H, if I use that as a transversal, where you have BJD, this angle here, and angle H, I'm just going to put 3 marks on that. That would also be a set of corresponding angles. So you could use either set. You just need 2. You don't have to have all 3. And I'm going to say here, we call the little bitty one, BDJ is similar to BFH. And again, I don't have any side lengths given to me, so I can say they're similar, but I can't tell you the similarity ratio because I don't have enough information. Yeah, you just leave that blank or none or not enough information, or just leave it blank, whatever is easier for you. Yes. All right, now, these last 2 really quick. This just says, could I prove, and I've got 2 different examples here. Could I prove these triangles congruent with just the given information in the picture? Okay, so on this first triangle, I have a set of sides marked as being the same, and an angle marked here, and an angle marked in the other triangle as being congruent. Do I, at that point, right, I've got angle side, spells a bad word, so it's not something that I've got on my list of things I can use as a proof. Can I have anything else in those diagrams that's maybe not marked already? No. That's not quite. What were you thinking? Yes, why? Yes. Okay, do you guys, those 2 sides are the same, so that's an isosceles triangle. So it makes those 2 angles equal. And same argument right here. So in that case, L and H are congruent, J and F are congruent. Okay, now let me ask you this question because I think this gets tricky. Your 3 options for showing that triangles are similar, you have angle, side, and side. Which one would be using here? Angle. Yeah, and it's very tricky because you have some sides. They don't tell you the length, but they do have labels there. If I did side, the angle would have to be in between the 2 sides. So this one would have to be angle, similarity. I don't have the 3rd side labeled, so I couldn't use side. Okay, now I got one more. If I see a picture like this, I would just automatically mark, I got vertical angles right there, right? Okay, now I don't have any sides marked here, but I do have these 2 sides marked as being parallel with that little extra arrow there. Okay, so I'm going to show you this. There's 2 different ways you could do this. If I used AP as my transversal between the 2 parallel lines, I would argue right here, angle A and angle P. Those guys are alternate interior angles. Right then and there, that's enough for angle similarity. Now, if you didn't notice that, same argument, I could use CM as a transversal there. And if I did that, I could get angle C, I'm going to put 3 marks on that, and angle M, 3 marks on that. I could get those angles, same argument, alternate interior angles. So this would be angle similarity. Can't do my similarity ratio because I don't have any numbers in the question. But if you see parallel lines, look somewhere for alternate interior angles or corresponding angles that you might find congruent. Is anybody having a question? Okay, so homework is super similar to the notes. So